Okay, Math 131, Exam 2, question number 1. If the cost C of x for manufacturing x units of a product is given by C of x equals x squared minus 10x plus 1200, find the number of units, that's x, we're looking for x, manufactured at a cost, that's C, of 4,200. Step 1, we're going to replace the C of x in the given equation with 4,200. And here is the result. 4,200 equals x squared minus 10x plus 1,200. Next, we're going to solve this equation for x. Well, it's a second degree equation, so we move everything over to the one side, and the other side will be 0. Then we factor the non-zero side, set each of the factors equal to 0, and solve. 1 gives us a negative answer, and x is a quantity of units we're manufacturing. You cannot manufacture negative quantities, so cross that out, and the answer is just going to be this one. At a cost of 4,200, we can produce x equals 60 units. Number 2, I see an error on number 2, and I want to repair it right now. So first of all, let's go and make this into black ink to make sure you write this in. Oh, down here in step 2, this should be not x squared minus 1 squared. It should be x cubed minus 1 cubed. Okay, keeping that in mind, I'll go back to my red ink. And, okay, we're going to completely factor 9x cubed minus 9, or tell us that it's prime, which means it cannot be factored. That's usually not the case if it's on an exam. I expect to see you doing some work, so I usually give you one that you can factor. Step 1, factor out the greatest common factor first. Now, out of these two terms, they have a common factor of 9, so I pull it out here. It leaves parenthesis x cubed minus 1. Now, here's the formula we're going to use to factor the difference between two cubes, x cubed minus 1 cubed. Applying that formula, we get, bring down the 9, then we have the first part of the formula, x minus 1 times the second part of the formula, x squared plus x plus 1 squared, and then the total answer is in the box. Now let's move along to the next question. Question number 3, find the special product. Oh, it looks like a plus b times a minus b, or vice versa, because you see it's 1/5 y minus 7 times 1/5 y plus 7. So this is the formula we're going to use. It equals first dude squared minus last dude squared. Now put parentheses around the first dude and the last dude, and we'll get it's equal to 1/5 times y squared minus parentheses 7 squared. Now 1/5 times y squared is 1/5 times 1/5 times y, which gives you 1 over 25 y squared. And then minus, don't forget the minus, 7 times 7 is 49. The next question, number 4, we're going to have 5x minus 7 to the second power. Now here's a little warning. Don't assume that means first dude squared plus or minus the last dude squared. There's no such rule. Instead, you have to use a definition of having this full base raised to this exponent 2. It is the full base 5x minus 7 times itself. Now you have to FOIL. First times first, outer times outer, inner times inner, last times last, and then you combine any like terms in the middle, and our final answer is 25x squared minus 70x plus 49. Question number 5, find the product of the polynomials. Parenthesis x plus 11 times x squared plus 3x minus 7. So we have a two-term polynomial times a larger polynomial. We're going to have to do a lot of distributing. So first let's distribute the x. X times x squared gives us this. X times positive 3x gives us this. X times negative 7 gives us this, but we're not done. Now we're going to distribute the positive 11 multiplied by each of the three terms. We get positive 11x squared, positive 33x, and minus 77. Then the last step is to find any like terms and put them together, and our final answer will be x cubed plus 14x squared plus 26x minus 77. That was number 5, and let's move on. Now we have question number 6. Factor the difference of two squares completely. 36x squared minus 25y squared. So I only put one step. We're going to use this formula because it's a difference between two squares. We have to really write it this way as a difference between two squares. That's what this is right here. So 36x squared is the same as parentheses 6x squared minus 25y squared is parentheses 5y squared. And then we use the formula on this side. It's a plus b times a minus b, which gives us 6x plus 5y times parentheses 6x minus 5y. Number 7, for the given functions f and g, find the requested value. So they give us f here, they give us g here, and they want us to find f minus g of x. So the first thing we use is the fact that f minus g of x is the same as f of x minus g of x. So using those definitions for f and g, it's parenthesis 2x minus 7, and then a minus sign, and parenthesis 6x minus 6. Now you have to carefully distribute the negative sign, and you'll get 2x minus 7 minus 6x plus 6, because a double negative gives you a positive 6. Then you combine like terms for your final answer, negative 4x minus 1. And finally, for question number 8, you're given f and you're given g. But this time, it's a different f and g, and you're asked to find something else. You're finding f plus g of x. So we're going to use this definition. It's the same as f of x plus g of x. We're using parentheses again. It's f of x, 6 minus 9x, plus parenthesis g of x, which is negative 2x plus 9. Now drop the parentheses carefully and combine like terms for your final answer, negative x, 11x plus 15. Number 9, simplify the poly by adding or subtracting. Express your answer as a single poly in standard form. Well, we have subtraction happening here, so the first thing we're going to have to do is distribute the minus sign, and that gives us 8x squared plus 2x plus 2 plus 5x squared minus 10. Then we just go through this list and we combine any like terms for our final answer, 13x squared plus 2x minus 8. And for number 10, find A, the P intercepts. P is sort of playing the part of x, and part B, the y-intercept of the graph of the function. Do not graph the polynomial. Remember, it's y equals s of p instead of y equals f of x. Okay, so it's s of p equals 2p squared minus 5p minus 7. First, the p-intercept, we let y equals 0 in the given equation here, and now we solve. It's a second-degree equation, so we factor. Then we set each of the factors equal to 0, and we solve. We got p equals 7 halves, p equals negative 1. Now it's important to write your final answer as ordered pairs x, y. We started by letting y equal 0, so the ordered pair is 7 halves, comma 0 for x, y, and together, union together with this ordered pair, x, y is negative 1, 0. Now the y-intercept's even easier. You take the given equation and replace the s of p with y, and you let x equals 0, and simplify, you get y equals negative 7. So the ordered pair for the y-intercept is xy equals 0, negative 7.